excited to introduce our speaker. Yamini Vellore is the CIO of Blume Global, and she is going to talk to us today about AI-driven supply chain in the context of COVID. Thank you so much for joining us, Yamini.
Oh, thank you for having me. Hello, everyone. I'm Yamini Vellore. Like I said, Cindy said, I'm a CIO at Blume Global. I've been in the supply chain industry for a little over 30 or so years. I've been on the software side, development side, where we built supply chain solution software. And I've also been on the implementation side at Hewlett-Packard, where we had implemented supply chain solutions that have been built by other vendors, right? So having sat on both sides, and now again, I'm on the software side of the supply chain solutions here, and have a unique experience in terms of connecting with both sides. Hopefully, you'll find this session informative and helpful for what you're planning to do. So let me go into a screen share mode. I'm sure a lot of you already have attended a few sessions where they talk about artificial intelligence. What does it mean, right? Essentially, we try our best to be relying on machines, technology, right? This is one of those times where technology is trying to become a human, right? It's just basically want to emulate how human intelligence and behavior would be. We make decisions based off of several aspects, visual, data in our head, and all these aspects covered, whether it is someone's body language, whether it is somebody's words, or what we see in front of us, right? We make all of those decisions based off of, every decision we make is based off of those multiple cues that we get. Technology, artificial intelligence is really trying to make that same decision for us based on all these other cues, right? If you break out your artificial intelligence, it's two big subsection, right? Human interaction or symbolic based, if you would, visuals, your speech, your what people hear, all of those aspects is one of them. The other one is data-based, right? When you look at data, that's where computers are able to process a lot more dimensions, a lot more than what a human brain can process today, right? So when you think about machine learning, deep learning, all of those are really based off of the amount of data, volume of data that you would get. So that's what we are going to cover at a high level today is how does it connect with supply chain? What does it mean from supply chain standpoint to use artificial intelligence, right? So if you go into COVID-19, we're in a very unprecedented time, right, across the globe. We started off February. We didn't expect this year to be this way. And yet we are here in October, where we never thought that we'll be working remotely for as long as we have. We have border restrictions, and even state and country borders are not allowing food and any kind of equipment to be moved around, right? So we're in a unique situation. Every company that's out there that's dealing with supply chain had to rethink, reprioritize technology investment because of COVID, right? Not only did we have to adjust because people are working remotely, we're in a unique situation. The patterns of supply chain also have changed, right? If you think about how we buy anything, right? Whether it is essentials, non-essentials, no one's going into the store, no one's ordering from looking at look and touch and feel, right? And it's really majority of the purchases have gone online, ordering, including essentials, everything getting ordered online. And the sense of instant gratification has increased. I mean, thanks to some of the leading vendors here, that have been online, have online presence quite a bit. We all want to know, where is my stuff and what turn is it making, right? Is it close to me? Which turn am I, is my goods coming in? And when is it exactly going to show up at my door, right? That instant gratification requirements have not gone away, whether it's COVID or non-COVID, it's just expanded. And complexities of how you deliver a package, how do you even mobility of resources. There's only so much you can order online, and at some point, a human has to come and deliver, right? We're not yet ready for drones to deliver stuff for us. But that's coming fairly quickly, but at least at this point, human have to come and deliver, in those complexities with those in terms of who is able to touch our stuff, who's delivering, and at the front door of consumers. Technology has been, I'll use a few examples of where technology has helped solve simple and yet also complex problems, especially in the COVID-19 situations that we are in. So if you think about most simplest part of it, right? We just touched on drivers who have to get there's no option of working remote for them. You have a terminal operator, ports or terminal, or warehouse operator. All of them have to be in person in order for supply chain to be continuing to function, right? So if you think about how things are, reduction in physical paper. So the way delivery happens is that you have people dispatching drivers. They have a piece of paper in their hand to say all the stops that they have to make. And there's proof of delivery that has to be signed off on paper. As much as we think we are digitized, vast majority of drivers are still handling paper documents, paper PO, proof of delivery, paper bill of lading and whatnot, right? So the first step is more people are looking for, drivers are looking for digital solution that are easy to use and cost efficient, right? Now, the use of mobile application for capturing proof of delivery, sign on glass, milestone dates and times of when somebody reached, when a driver picked up stuff, when they delivered, all of those are mobile driven these days. Plus the additional piece of benefit here is your GPS or real-time tracking and visibility. As I said, consumers are demanding instant gratification, right? So they want to know where their delivery is, and the requirements for tracking and real-time visibility is increasing, and every person in the food chain wants to know where my stuff is, and they're demanding their customers to be, and their vendors to be able to provide that. The benefit of artificial intelligence here is that as you go drop off or pick up in a warehouse, you're able to do geofencing of that location based on the lat long of that mobile app and where the truck driver is and the truck is, right? Whether it is a GPS unit or a mobile unit, you're able to geofence. And this is something that's going to come in handy when you are actually settling settling invoices, right, amongst multi-party here. How long has someone been? There is a delay or wait time of an hour at your distribution center because you showed up late and you missed your appointment, or did the driver get there on time but just was waiting because the dock door was not available, etc. Right? So those are benefits of doing this here. So that's a simple example of how things are. Artificial intelligence can help here, right? A little bit more complex example here is within the warehouse. If you think about automation in the warehouse, whether it is self-driven forklifts or robots that are picking items that needs to be packed and delivered, shipped out of the warehouses. As you know, the distribution centers and warehouses were built separately, right? Whether it is e-commerce or for bulk shipping, right? If they were definitely separate data center, distribution centers set up where you pick one or two items for an order versus you're shipping a pallet of the same item for an order. What warehouses and distributions where companies have to rethink their strategy now is majority, the volume has been gradually increasing over the last years, but with COVID, things have changed dramatically, right? Overnight, everything is ordered via online. There's no store that you're shipping bulk items. You're shipping everything from one item versus one or two units from the warehouse itself, right? So everyone has to rethink their strategy of how they're automated in the warehouses or distribution centers. So e-commerce order fulfillment necessity for all distribution centers, social distancing, right? You can't have the volume of things that you have to go pick in a warehouse as onesie, twosie items. Social distancing is creating a special, unique situation where you can't have more people in the warehouse in order for you to keep up with the demand, right? So there's definitely requirements for automation and providing small human-less equipment that you can use to pick and deliver, right? So that's a little bit more complex compared to what we just saw from driver side. And further complexity here, right? Here is, you think about technology, congestion at ports, right? When we started with the COVID situation back in March, for a couple of months there, no one was shipping anything. Everything was on hold. Borders were closed. And even those that were shipped stayed at the ports for a long time because no one was willing to come and pick it up. But as time went by, with the last few months, what we see is that the volume has increased so much in terms of downturn that we had. It's compensating, plus the peak season is now, right? Right before we get to Thanksgiving and Christmas timeframe and the holiday timeframe. The peak season is, the natural peak season is also during now. And in addition, for whatever was not shipped before, we are now compensating, and you see the ports and terminals are flooded and everyone is struggling to keep up with the volume that's coming in, right? There are two parts here that I'm going to talk about. So there are visual cues that can help us, and there's also data-based solution here, right? When you look at delays, there's this visual cue here is all of these cranes that are there. When a particular day, one of the cranes are 1/3 of them out of the 3 is not working, for example, right? One is stuck and you can see visually that the others are getting picked up. That's a cue for artificial intelligence to say, camera-based, I can see that for the last half hour, one of the crane is not working. So essentially, automatically, your amount of congestion, how long it takes for someone to take the containers off of these steamship lines and make it available is going to be slowed down. If you only have 3 cranes per steamship line, as an example, your throughput is going to be 1/3 less, right? So that visual cue is essentially a person making that decision to say, I know I'm going to be slower today because one of it is on maintenance. One of my cranes is on maintenance, right? That decision can be automatically made based on artificial intelligence, looking at the camera feeds, right? And making those decisions automatically. Now, on the other hand, we're in a unique situation. You can have peak hours, seasonality, but we are in a situation which is much, much more than the normal seasonality variances. And as some of you might know, in our LA Long Beach area, we have so much backlog in terms of getting containers out, essentially because of amount of traffic, amount of containers trying to get in and out of that those ports and terminals, right? If you think about that, you need self-learning prediction, right? So normally it takes 2 days on average for a container to be off of a steamship line and be available for the cargo owner or their affiliate to come and pick it up. During these situations where we have so much more coming in, the 2 days, maybe 4 days, maybe 6 days, right? So being able to predict based on the last few examples of the last few days, correlating it with all of the other seasonality and peak hours, and ensuring that appropriate lead times are updated. So that's, you don't want a driver to go to the terminal and sit there and wait, or be collecting detention and demurrage when something's already out, right? So there's self-learning prediction that artificial intelligence is going to help you with, right? When you are looking at other congestion here based on labor or equipment, you know, availability of equipment, whether it is a chassis that you need, or you need a driver, and there's a driver shortage or a chassis shortage, which is becoming very common these days, essentially because of the volume of shipments that are coming in. So those are things that can be used in order to predict and essentially come up with a lead time, so you're not you're able to adjust your requirements, or as a consumer of these, you can adjust your shipment availability and when you send your resources there to get these containers out. So that's a little bit more complex scenario here, but essentially what we are saying here is that the amount of time we spend in terms of making these decisions, someone making a call by looking at things using visual cues and others, can be reduced dramatically, and even beyond what a human can connect and say, okay, this I'm looking at now thousands of additional yards and others where availability is there for my chassis, and there's not enough availability, so I can predict ahead of time that a normal Thursday during the month of October is going to be this heavy, and I know I will have probably less than 10% of equipment availability. But this time of the year 2020, which we'll probably be speaking about for the next several decades, right? The year 2020 is going to be unique. And year 2020, knowing what we know from the last few weeks, I know I can expect 0% availability. And so people have to make their reservations ahead of time, right? So those are type of things that can help with decision-making in supply chain. There are only a few things that I covered here. There's just tons of more complex problems that even human is not able to solve quickly, right? Or make a prediction, that we could use artificial intelligence to make these predictions. I picked individual examples here to share, right? But just generally, if you look at this, you have, I'll use some specific examples. When you think about, I'll keep this to a transportation related item, right? If you're shipping something from Asia into US as an example, on average, there's about 16 to 20 handoffs that happen. This is only average, right? The largest handoff is like more in the 50s or 60s, right? How many different parties that touch or handle that particular container, if you take this as a container coming from Asia to US, right? Before it reaches the final destination. So it's a lot of touch points, and touch points, handoffs. On the other way of looking at this is points of failure, potential points of failure, right? How do you ensure that there are no disruptions in those handoffs and there are no significant delays? So ultimately, an hour delay at a railroad where you missed a train from taking this container does not mean an hour delay for your delivery, right? It can potentially mean that it's now a day and a half delay before you can hand off the container to the cargo owner. So those are the things that we need to account for here. And those are things that we can essentially calculate to say, visibility is important. I want to know where my stuff is. At the same time, I also want to know when I should expect this to show up where it needs to be. And if I miss any one of those average 16 handoffs, what do I have to do? I have to be able to change the execution. I have to be able to say that now I'm going to change my plan. I probably am not going to send it via train anymore or rail anymore. I'm going to now have somebody else drive this entire way, right? So there are other suggested alternatives that system can come up with, predictive and execution and visibility combined together. We're able to make decisions to say, okay, my predicted ETA is not sustainable. I'm going to have chargebacks from cargo owner, and I'm going to have other penalties. So I would probably pay an additional amount in order for me to take the alternate path, right? To get to deliver the goods on time. That's an example here, your GPS and ELD solution. So there are, at a high level, you can think of GPS as, okay, it's just telling me where I am, right? Your ELD solutions are a little bit more sophisticated. It could be capturing when the door gets open, when the door gets closed. It could be temperature controlled. So as an example, I'll talk about milk here, right? Or vaccines, where that's probably more appropriate here. As soon as we find vaccine for whatever situation we are in for COVID, vaccines have to be distributed. And it is absolutely important for us to know that these vaccines have to be at a certain temperature. And it's not enough for you to say, when I'm picking up, when I'm taking delivery of that vaccines, I'm at the right temperature. You also want to know that the medicine stayed at that optimum temperature the entire path of wherever it came from, right? That part of it can be handled by your ELD. And when you think about ELD, it produces so much data, right? How do you make sense out of that data? How do you know that this example of it needs to be less than 25 degrees or 30 degrees, right? My vaccination has to be 30 degrees across where it got packaged from, where it's delivered. There's no easy way for us. So let's say for an hour, there was no power along the way, or the air condition wasn't running, the temperature wasn't there, and suddenly your vaccine expiry date will have to be adjusted because it's not the same anymore. It's not maintained in the same temperature as it got to the destination. It went to 40 degrees for a half hour before it came back to 30 optimal degrees, right? So those are types of things that can be handled by artificial intelligence. It's not humanly possible for someone to say every single vaccine that's out there, if it stayed in the optimal path or not. So you want to be able to allow data to be manipulated, to be reviewed, not manipulated, really reviewed, right, via artificial intelligence. And you only want users to hear exceptions. Hey, this out of the 50 containers that I shipped, this one had a temperature problem, and you want to focus on that one. The rest of them are fine, right? And it's not a point in time, starting point and ending point. You also want to know somewhere in between. So that's one example I can see here, right? That more of our customers are starting to use and starting to realize that when I'm shipping perishables, when I'm shipping vaccines, I have to keep track of all of these things. And vaccines need to reach on time. So it's not enough for me to say, I'm delayed by 2 days, I'm delayed by a week because I missed one of the handoffs we missed, right? It's life or death for many people, unfortunately. And we want to make sure that we're delivering it as promised on time and people are able to be treated with the vaccines, right? So moving on to the next topic, I guess, location accuracy. I touched on it a little bit earlier. geofencing. There's for those that are tracking the movements and capturing milestone events in real time, there's a lot less time that's spent after the fact disputing invoices, figuring out who owns what part of your invoice and charges, right? There's detention, there's demurrage charges, that's constantly, storage charges that constantly come into play, where you have to figure out who's going to pay for this extra day of storage in whatever location you might be, right? So these are things that can capture real-time information, and you can use artificial intelligence to match what is being charged in the invoice and what the reality was in terms of when these milestones were captured, to determine if this is something that needs to be triggered for an audit, or you can pay, right? So it's just a lot less time that you have to spend dealing with disputes. And we touched on availability of equipment. Again, this is not just availability in terms of what I need to pick up and I need in terms of fulfilling my moves, but let's say you're delivering to a distribution center, you've delivered to the distribution center as a driver, and what happens after that? Now, am I driving empty all the way back, or am I to the port or a terminal, or am I able to pick up something else close by and use that, right? And then the other piece of that is, are there things that I can go do in between? Instead of driving empty, can I pick up some other load and drive back, right? Repositioning empties. So these are things that can be provided as part of artificial intelligence. And you don't want someone to be sitting there looking for this. You want someone to, the system to tell you that, hey, you can do this, right? And then human can make the decision as to whether they want to do this or not, right? As you build your models, your intelligence models, initially the way we've implemented this is that you have a situation where system is telling you these opportunities and exceptions that you need to handle, and human makes a decision on what you want to decide whether this is the right thing or not the right thing, right? And there's self-learning based on those decisions, and you can see that the next time the exception or recommendation prediction and recommendation comes, it would have already taken care of the previous human decision, right? So once you've perfected that by making these decisions, then you can automate these decisions and not have to have a human making those decisions, even on those exception scenarios. So that's kind of what I wanted to cover, right? So if you think about all of these, the orchestration of this whole thing is more like a control tower, right? You think of a control tower, it's just artificial intelligence enabled. If you want to be able to get real-time insights, you want to automate exception management, you want to provide predictive analytics to say, okay, here are things you want efficiencies in your supply chain, right? And deliver business value in order to make it efficient for yourself, for your customers, your vendors across the board, right? But all the examples I gave so far are point solutions, right? Okay, individual, transportation related, warehouse related, driver, carrier related type of thing, right? However, all of these things can be handled at an overall view, right? If you take this example, I use one of these slides from our company overview. The way you look at AI-enabled control tower here is that we integrate a problem in one area, let's say transportation, will impact planning, will impact how you deliver on time, how you have to change your ordering system or manufacturing, all of those things, right? Your capacity for freight, cost management, every little bit of it have to be covered, right? So you start off with one system, individual systems, but that doesn't stop there, right? Your control tower gives you a higher level picture of how you have to connect other systems, whether it is a planning system, execution system, logistics system, your order fulfillment, any of those across the board. A decision in one place impacts everyone else. So the control tower is essentially what will help you make these connections to make appropriate decisions, not just in a silo, but also to look at across the board, right? So Blume Global, where I work at, we have a solution for control tower, and this is something that we've implemented for our customers, and wanted to certainly bring that up to say it's not a point solution. When you think about implementing artificial intelligence in your supply chain, you start with a point solution, and then you expand it up to control tower, where you can look at across all solutions and also make those connections, right? And some other examples of how you can enable agility, right? You can flag and quantify exceptions, machine learning assisted exceptions, right? You can resolve them automatically or through a human resolving them. And you can see the impact, right? You can see customer satisfaction, improvement in customer satisfaction, because you're able to handle this dynamically, all these unique situations and handoffs that you have, right? You're able to handle those dynamically and take care of customer satisfaction. Then you know you are building confidence in your customer with your customers. So this is my last slide here. So I will stop here, and if there are questions, certainly I can answer those.
Yeah, absolutely. Thank you so much. It's so interesting. So folks, feel free to put your questions in to Huva in the session Q&A section, and I will ask Yamini about them. So our first question is, back in March, the toilet paper hysteria, like how can AI help in the context of an event like a natural disaster or COVID, in trying to sort of better predict and better, get the right amount of supplies to the right areas?
Yeah, good question, right? So we've all seen that pandemic happen, right? Everybody's looking for toilet paper and hand sanitizers and whatnot. So one of the things that we see here is that this is a totally unprecedented, unexpected behavior, right? So everyone had to change the way they think. So if you think about where originally when things were thought of as, I'm gonna have a 40-day, 50-day lead time where I'm gonna manufacture, and I know I'm gonna get things into local areas where the needs are, and then I'll keep them in stock, and then there's enough stock, first level, second level, third level of stock before it runs out, right? But all of those got put into test. So I think I mentioned this earlier, 2020 is going to be a year of where supply chains can learn, supply chain network is going to learn for the next few decades to come, right? These situations is where we've seen customers change the way they've prioritized technology over what was not prioritized before. How quickly things that were stuck in borders and because of other outside areas where things got put on hold in March, those were brought into light based on artificial intelligence, knowing where my inventory is, right? So previously, importance for where my inventory is was not there. It's important once it reaches my destination, or once I know when it's shipped. In between for 30 days, I know it's going to come, right? But I'm not interested in where it is in along the ocean, for example. But that changed now, right? So the artificial intelligence and what we have implemented is that pinging across the ocean, pinging across the railroad, knowing exactly where not just my consumer related item is, but the bulk of all of my shipments that I need to fill for stock where it is, right? So it became more important, and that's where the amount of data that you're getting from all of these, implementing a satellite solution to say where it is every 5 minutes is great, but who's going to look at that? It's not possible for a human to look at, right? The artificial intelligence is really what you need here in order to say, only show me the exceptions, don't show me everything, right?
That's a great example, and especially for the large, the large organizations where you can't possibly see it all.
Right.
Which leads me to my next question, that this seems to be this reliance on AI for a more efficient supply chain. How is that setting up the larger organizations, the Amazons and the Shopifys of the world versus the mom and pops? And how do we try to help them, the smaller companies, to make sure that they're not getting left behind?
Great question. Great question. So a little bit of marketing, if you from Blume Global, if you don't mind. I think that's one of our motto, right? Democratization of technology. Whether they're a small mom and pop company or a large organization, technology should be available to everyone, right? So that's our motto. And so as we're building our solution, that's actually what we're looking at, whether a company with one truck or thousands of trucks, they should be able to afford technology the same way. And so they can compete in the same market, right? That's an example that I'm using as a trucking company. I mean, that's where there's so much variation. People who have one truck versus thousands of trucks, and their affordability is quite a bit different, but our motto is to bring digital capabilities regardless of the size of them, right? And what they can offer. So that's just talking about Blume Global here, but in general, this situation has brought in a lot of technology innovation, affordable technology innovation for every small organization that's out there to be able to afford technology and be available in the marketplace, just like the large guys out there.
That's really cool. And it sounds really important and necessary.
Right.
And then let's see, talk to us about, you said that there are scenarios where there are 50 or 60 handoffs. I've never heard that before. How is that possible in 2020? How is that happening?
Yeah, that's exactly right. That's the average is 16 something, right? But if you look at the skewed numbers, there's just so many handoffs. But if you think about manufacturing in Asia location, right? Somebody manufactures, and then they're saying, I'm ready to ship something. There's a handoff to a third-party company that's going to take the container. Let's call a container simplistically, right? I'm not touching individual items. I'm taking up an entire container. That container needs to get to the port, right? Let's say it's shipping to you. It needs to get to the port, and it's not always that entire container. So somebody might be saying, I only have enough for a quarter of a container. So someone else, a logistics service provider there, is actually consolidating. They're taking it to a container freight station, consolidating maybe a quarter available capacity in one of their other containers. They're loading it in there, and then another person is driving it over to the port, right? Then you think about the port handling. There's a handoff there for someone to take it from there, move it to, and put it on the steamship line. And then, of course, the majority of the time is really coming into, let's say, United States in one of those ports. It's almost exactly, or if not multiple of those handoffs happen there. And in the interim, while things are here, there is no physical handoffs, but there is still handoffs from customs standpoint, being able to prove that this is what is in here is valid, it is what it is, right? And there's all of that has to happen. So it's hard to imagine that that's how many touch points. And we've had a study done, right? And there are plenty of studies out there, if you search about how many handoffs happen. If you think about a manufactured item that's sitting in a different part of the globe coming into US or any other parts of the world. It's a lot of touch points. I had to read a few times to even accept that, oh, it could be 60.
That's amazing.
Yeah.
So we are at time, and I want to be respectful of everyone's time. Thank you so much. This was fascinating. And I'm just really appreciative of your time and your expertise. And so we've got a break now. For those of you, for attendees, we have a quick break. At 3:45, we have a session I'm really excited about, just a little breakout called like from TikTok zero to hero in 30 minutes. And we're gonna talk about the algorithm, how TikTok is so incredibly sticky, how they're making the algorithm work, and then we're actually gonna try to do our own TikTok dance. So tune in for that, bring the kids, and then at 4:15 we've got Marlon West. He is live, and we'll be talking about how artists and engineers are working together to create more creative animated worlds than we've ever seen before. So thank you again, Yamini, and I will see you all hopefully in a half hour at Marlon's talk, if not in the TikTok session in 2 minutes. All right.
Thank you, everyone. Thank you, Cindy.
Thank you so much. Bye-bye.
Okay. Yeah, bye.